Welcome to Lesson 8 from Chapter 11. This is display measurement, data in a line plot. So data is information collected, and how you're going to show it, display means show, how you're going to show it is on a line plot, a line. A line plot basically means you have a line, you have increments, and then however many you have of each number, you add to the top with an X. So you can represent measurement data for fractions of a unit in a line plot. The line plot's number line will look like a ruler. Okay, so let's look at this one. So here we have our line plot, the data. The science room has a collection of bugs. Each bug's length is measured to the nearest eighth of an inch. Make a line plot to represent the data. Okay, so everything's the eighth of an inch. So say started at 0 and ended with 8 out of 8. So you start with nothing and you have a whole inch, 8 out of 8. And then they drew these arrows in the end to show that it can continue. So first make the number line to represent the value. So that's your first step. We know it's eighth of an inch, so that's the increments. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Okay. And then they measured the bugs. So we don't actually have to measure the bugs, but there was no bugs at 1/8. And there was 2 bugs at 2/8. So I would be putting 2 X's here. And they've done that for us. One bug at 3/8, so I would put 1 X. And they did that here. 4/8, there was 2 bugs, so they put 2 bugs. 5/8, oh my goodness, there was 6. So 1, 2, 3, 4, 5, 6. 6/8, there was 5. 1, 2, 3, 4, 5. 7/8, there was 4. 1, 2, 3, 4. And 8/8, there was 1. Now, this is very important part, is this next place an X above each measurement every time. You have to make sure that it's straight. Okay, do you see how these X's are very straight? And then the next row, they're straight across. And then the next row, straight across. And the next row, straight. Because what's going to happen if you do it like one big X and a little X and a little X, when you look across, you're going to think these are about the same value, but they're not. Because you should be able to look across and see that the highest one is the one that has the most. But if you make your X's all uneven, you won't be able to really tell. Okay, so very important part, you have to make your X's about the same exact size and kind of put a space between each so that they're even, they're straight. Example 2. Refer to example 1. Find the difference means subtract, in length between the longest and the shortest. To find the difference between the longest and the shortest, subtract the shortest from the longest. So back over here, the longest was 8/8, and the shortest was 2/8. So then they subtracted 8/8 minus 2/8. And we know that when you subtract fractions, you have to check to see if the denominator is the same. It is. And then you leave the bottom the same. Leave the denominator the same and subtract the numerators. So we have an answer of 6. And then this is simplest form. Remember that? Because you have to divide by the same thing. Divide by 2, 3, and 4. Simplest form. So they've just put it in simplest form for us. The difference between the longest and the shortest bugs in the collection is 3/4. So normally in the problems they'll have the original problem which has the data, and then they'll always ask generally a follow-up question like this. Okay, draw maybe a bug that you think they could be. I'm going to draw a grasshopper. My version, oh no, I think I did his legs wrong. They don't have like a double thing like that. Yeah, that's more like a grasshopper. This one's a grasshopper hybrid. It's got special springy double legs. Oh no. Okay, I will see you in class for more data displaying.